Hi, today I want to show you patient memory, how Clinia helps AI actually work in healthcare. So as we know, AI in healthcare is moving very fast, but most deployments will always hit the same wall. The underlying patient data, which is an example that we can see of right here, is fragmented, duplicated, and full of gaps. And you can't build reliable AI on unreliable patient data. Patient memory solves this by continuously capturing, structuring, and connecting every piece of patient data across every interaction. So the AI that you're building will always have a complete, accurate foundation to reason from. Coming back to patient memory here, before we begin, just a quick note. Patient memory is a backend service with no UI. So what you're seeing here is a very lightweight demo interface that we've built to make the capabilities a bit more tangible. So we're using John A. Smith today as our demo patient. As we saw here, John's patient record is very intentionally complex because real patients will be complex. So we've ingested a very large FHIR bundle. We have imaging files, PDFs, XML documents, CDA documents, just tons of patient data. This is the kind of data that health organizations deal with on a daily basis, and I'm going to show you how patient memory is built to handle it. So when the data comes in, patient memory doesn't just store it. It processes it, it resolves it, and it keeps an auditable record of exactly what was done. As we saw, John's raw record contained roughly 4,000 clinical entities, and after deduplication, we're down to 1,444. That's a 64% reduction with no loss of clinically meaningful information. And those entities cover the full picture: conditions, medications, lab results, and more. And it's all deduplicated, normalized, and ready to reason against. So as you can see here, we have a few examples of us deduplicating the information and normalizing it. So deduplication is just step one. Step two is where it gets interesting: inference. So patient memory will infer relationships that don't explicitly exist in the source data. So which medications are treating which conditions, which labs are monitoring which conditions, and then which conditions are likely complications of others if left untreated. So here, for example, we have auditory hallucinations. It was inferred that this is a symptom of bipolar affective disorder with a confidence level of 0.7. So we do this by reasoning across standard medical norms: RxNorm, SNOMED, ICD-10, and LINC. Agents operating without this relational context will hallucinate. They'll make confidence-sounding connections with no clinical basis. Patient memory eliminates that risk by giving the agent a relationship layer that it can actually trust. If we take John's type 2 diabetes condition as an example, patient memory has captured every instance that it's been recorded across his medical history and every lab that's actively monitoring it. So we have full clinical context built from the data. And now we have a rich, structured knowledge graph for John. The next question is, how do agents actually use it? Patient memory exposes the patient graph as a virtual file system. Agents are natively good at navigating virtual file systems, and so instead of building a custom interface, we meet them where they already work well. It's self-documenting and designed for efficient exploration. From there, patient memory surfaces 3 different tools for agents to interact with this graph. A search tool, which is a grep equivalent to find specific entities or concepts across the patient record. A read tool, which is a cat equivalent to pull full details on a specific entity. And a browse tool, an ls equivalent to navigate the structure and see what's there. So you can connect via our MCP server, and you can build a conversational interface on top of patient memory in minutes. We have an example here of what that could look like in practice. So this is an agent that we've built on top of patient memory. I'll ask the agent to build a patient summary. So you can see how patient memory makes that possible faster and with far more context than traditional approaches. So what's happening here is that the agent is calling the tools in real time, but it's patient memory's structured graph that makes each of those calls fast and meaningful. So we're not digging through raw data here. In seconds, we have demographics, active conditions, current medications, allergies, family history, lab highlights, the full picture. That's not the agent being smart. That's patient memory having done the work upstream so that this comes up clean and clear for the clinician. Because patient memory holds a structured, trustworthy record, you can keep querying it. I'll ask, is this patient's CKD being adequately monitored given that it's a complication of their diabetes? So same result here. We can see the tools being called in real time. And here we have it, the result to our query. Instant, accurate, grounded, because the agent isn't guessing. It's reading from a patient graph that patient memory already built and validated. So we have here the answer to our question. And there you have it. That's patient memory. A unified 360-degree view of a patient built from health data and learned context from agent interactions. Purpose-built to give your AI agents the foundation that they need to reason accurately. Thanks for watching.